The best well-kept secret metric in the industry, Part 2. If you missed the few presentations we did in 2021 and 2022, Dr. Woo-Keun Song from HBK developed a new innovative objective metric to estimate audio artifacts in the audio reproduction. We call this new metric BSR, or buzz, squeak, and rattles. BSR takes into account everything else that deviates from the DUT device under test linear response, including the low, high harmonic, distortion, drops, pops, hiss, etc. What is truly unique here is the BSR metric is based on an advanced time-varying loudness, which estimates how human perceive sound, including time and frequency masking of the human ear. Here's the block diagram of the metric calculation. In previous presentation we used lock sweep as a stimulus, while now it is possible to just use music or even speech. We still use one microphone to measure the device response, including all kinds of potential artifacts. The top branch of this block diagram shows that we will feed the full response with artifact in a time-varying loudness analyzer that will be represented by an NY curve. The bottom branch uses circular deconvolution and convolution with the input signal to extract the stimulus, or the source, from the audio response. Then, once the source is extracted, we can fit it in to the time-varying loudness that will be represented by the NX curve. If the device or speaker doesn't have any artifacts, the difference between NY and NX should be close to 0. If NY deviates from NX, it means we'll have a device with artifacts. Let's take a quick example of an open loop test using my phone, and I'm going to play 15 seconds of Magic from Coldplay. If you don't know that song, it has a lot of bass and drums, and it should stress the micro speakers on this phone, revealing all kinds of artifacts. We just finished acquiring the data, and the BSR app overlays the NY and NX curve on the top graph. Look at the difference between the two curves. Additionally, the application displays the difference between NY and NX over time. Finally, the application calculates the average loudness difference in sounds, and this is what we call the BSR, or buzz, squeak, and rattle. Low BSR means we have measured a device with low artifacts. High BSR means we have measured a device with high artifacts. Additionally, the BSR application exports the impulse times response and also the residual as WAV files. The residual is the difference between NY and NX. So in few words, you can only listen to the artifacts if you want to. Thank you everyone. If you'd like to test this human domain metric, feel free to contact me anytime.